Hey everyone, welcome back to the lab. In this video, we're going to be talking about speeding up some random row selection queries in Postgres by 8x with F# and Entity Framework. So I'm currently building FullstackProjects.xyz, a site that generates full stack project ideas. Its initial version is a simple MVE, or minimum viable experiment, providing randomized ideas to look through. Now these ideas are stored in a Postgres database, so each time I need to provide new ideas, I need to query the database. My initial attempt at this led to queries taking around 800 milliseconds, or about a second, which is much too slow for such a simple and core feature. For something you do very not often, this is probably fine, like saving a settings page, but for something that's like the main feature that you're going to be doing a lot, especially for the kind of app I have where I'm just generating ideas, this is much too slow to be on the hot path. And so in this post, we'll talk through how I optimize these random row selection queries in Postgres to achieve an 8x improvement, going from 800 milliseconds to 100 milliseconds with the same user experience and system architecture. Okay, general overview of full stack projects. This is kind of what it looks like. And I've got to open another browser and I'll show you what it does. Okay, here we are, FullstackProjects.xyz, and it just gives you a bunch of ideas. And you click generate new ideas and it keeps doing this. And so basically the problem was previously this was taking 800 milliseconds, and considering I'm trying to like give you a bunch of ideas fast, that's like too long to be waiting on a stupid button to have like a stupid list of items. And so the way it's built is it's a simple SSR website hosted on a monolith. So no real frameworks, just HTML, powered by HTMX. It's pretty great. And my initial version utilized encode lists as a data store. So imagine just like two long lists of items that is literally in my code base, and I just take a random index of that and return it. So that's like very fast. But the problem with something like that is, as you're trying to evolve a system, you kind of want a data model. And for the most part, you're going to be working in entities, like there's items in your data model that you want to build from. And so it's hard to evolve these things that are just in code somewhere. And so you kind of need to move towards some sort of data model, data store to evolve. And that's why we're kind of in Postgres land now and kind of dealing with these issues. So system design is here, should be pretty straightforward and familiar. F# backend Postgres database, and then front end with HTML powered by HTMX, which is basically how I'm building all of my projects these days, as I've mentioned in the ham stack, mentioned in Cloud Seed, stuff like that. And so this new model of moving to Postgres means that I'm now doing frequent retrievals of randomized items from a moderately sized SQL database table. And when done naively, as we'll see, this can lead to very poor performance. And so in my case, this was taking the 800 milliseconds for each query, which was much too slow for this user experience for this core feature. And if this were to ever actually get users, it would not be very scalable if every time we're waiting 1 second and thus hogging, the database's power. For more on the ham stack and how I build most of my projects, you can look at Cloud Seed at these links. All right, so that's what Full Stack Projects is. Now let's look at this naive randomized query that I was doing that was taking like a second to run. And so I'm using Entity Framework as an ORM for my F# app, and you can learn more about how I do this here, which allows me to query my database using F# without writing raw SQL. This can be both a good and a bad thing depending on the situation. Now for my initial version, I did the dumbest thing I could think of, and that I vetted with the internet and my AI, which is to simply order my data store by random value, in this case a GUID, and take the top X items that I wanted. And so here's an example of that. We've just got a little function, get random project ideas, that powers that front end that I showed you earlier. It has a service tree, which is basically how I do dependency injection in a semi-functional way. And then it takes an account, which is how many ideas do you want, and then it returns an async project idea list so that we're not blocking. And so here we get the database context, and then we're going to get the results. We're going to look at our database context. We're going to look at the project idea table. We're going to order it by GUID.newGUID. And since this is randomized values, the ordering will be random. We're going to take count, and we're going to do toList async. We're going to turn this into an async, and then we're going to return the results. So that's it. Pretty simple access. And to be fair, this actually works pretty well, right? Like this is real random, which is nice. And real random often has performance hits compared to like fake pseudo random. Although this, could be argued this is pseudo random as well. It's very simple to write and understand, right? We're all in F#, we're all using Entity Framework, no raw strings, SQLs, anything like that. And yeah, you just uses EF. Now the downside of this, of course, is that these queries are very slow, and it's taking 800 milliseconds. And here I'm in my Chrome network tab, and I just screenshotted a bunch of back-to-back requests here, and we can see that, they're taking about 800 milliseconds. Some of them are a little faster, some of them are a little slower, but about 800 milliseconds each time. And so this is probably too slow, but to figure out how to like fix this, you kind of think about why it's happening. And, you know, if I really cared about this, I'd probably use like Postgres profiler and stuff like that. But this one's pretty clear why this is happening, so I didn't even bother. And it's like, if we think about it, the likely reason for the slowness was that we were ordering the entire table just to pull a few rows out, right? We look at this and we're ordering by this. So the entire table just to take a small amount. We know that this is 5, but it's just a much smaller amount than we're actually ordering. And so this is a lot of wasted work. And worse, we're ordering on new randomized values that the database doesn't know anything about, so it can't do any sorts of optimizations based on heuristics or indexes or anything because it doesn't know what those values are. So a lot of times, if you're ordering by something that's in the database, it can understand some things and do some optimizations, but with purely dynamic values that it knows nothing about, it's going to have to do the stupidest thing possible because it just doesn't know what to do, doesn't know how it can optimize. And generally, this is just like a slow approach to doing things anyway, because even if we're using an in-memory list like I was doing in the first version of this, if we were trying to do this, it would be an O(n login operation just to sort the things, just to get a few items out, which was clearly too much work for something, especially something on the hot path. Okay, so how do we get the 8x faster randomized queries? What did I do from here? So 800 milliseconds is just too slow for a frequent UX flow like this. Ideally, it would be less than 250 milliseconds, which is kind of the heuristic to make a web page, a web action feel snappy. And so I started searching around for alternatives that worked well and were simple to implement. Now, the top answer for doing something like this, especially in Postgres, seems to be this table sample Bernoulli function, which allows you to get a much faster retrieval of some percent of rows. And so, for instance, we could do something like this, take everything from a 5% sample of this, and then we just limit the number we want. This works because, we know we have a very big table, so we can just put a percent in here that we know will be larger, and then we can limit it to the smaller amount here, and that's how we can get this pretty fast. And to be honest, this is probably like the right answer. Like, this is the bulletproof option for prod, and if you're like at any sort of scale, this is probably what you would want to choose. But for this, we're not there yet. We have 0 users. And I wanted to stay inside Entity Framework as much as possible and was reasonable because I like a lot of the type guarantees it gives me, even if we don't get to use all of Postgres' goodness. And so I looked for other options. And I was looking for other options, and a naive option popped up that was to simply take a chunk of items using randomized indexes with skip and take. And this is basically like you have a long list of items, and instead of individually taking, each item and selecting one at a time, you're just like, I'm just going to pick an index and I'm going to take the items that are grouped there. And so you only do one access. You still get semi-random, although it's really chunks, not items. But for most purposes, it's fine. And so the downside, of course, is it's not giving fully random. You're only doing random chunks and not random items. But the upside is that it's very simple, fast, and can be done in Entity Framework directly and plays well with, SQL databases. And so for my cases, we don't really care about full random, and it's unlikely that anyone's going to notice that we're doing chunks instead of items. And so this was a good balance for me to go with. And so this is kind of what it looks like. You can see we have the exact same definition here. And then the only thing that changes is how we go about this. And so we do one round trip here to get the count. Theoretically, this is fast because the database should be able to know like, oh, I haven't changed count yet. And so it should be able to do some caching and do this very quickly based on its heuristics. And then we're just doing an in-memory random here to figure out a good index, trying to avoid the end of the table. We know this will work because I have a ton of items, so it will never be like count is larger than the items in here, though of course you might want to check for that edge case. And then finally what we do here is we just skip to that random index and we take the count we want and then do toList and return the results. And as we'll see, this ends up being about 8 times faster. So we get around 100 milliseconds returns for this, for that same interaction. And we can see those here from my network tab. And I can show you this is actually what we're doing here. So this is, if I click generate new items a few times, we'll see it. It was a little slow on the initial query, but now that it's warmed up, we're getting consistently around 100 milliseconds for all of these. Make it bigger so you can see. And then just quick aside, you'll see that all of these are HTMX pages or requests, and that's because this is an interactive island right here, and so we only need to reload this portion, and so that's how we can get these very clean network requests and see exactly what this component took. So I love building little side projects because you run into all sorts of tiny puzzles like this one that you haven't really thought of before. I'm planning on playing with a few more features on FullstackProjects, so stay tuned for that if you're interested. Question for you is, how do you query random items from your data store, and how do you do that performantly? And if you like this post, you might also like generating full stack project ideas with F#, the HAM stack, a simple scalable tech stack for building modern web apps fast and cheap, or you might be interested in how I host my server-side rendered F# site on Google Cloud for less than $1 per month. That's it for this video. Thanks for watching, and I'll see you in the next one.